on this computer. All right, so let's get started. My name is Vaibhav Fadnis. I co-host this meetup with Michael Chung, who's right here in this call today. Thanks everyone for joining. We have Chen from ROS-Industrial Asia Pacific, who's going to talk to us about the work he's been doing. I'm going to call on Chen to introduce himself the right way. So Chen, go ahead, introduce yourself, and then you can get going with your talk. I guess we'll listen to your presentation slides for about 25 to 30 minutes, and then we'll have question answers. Okay. Yeah. All right. Over to you.
Thank you. My name is, so good evening, everyone. My name is Bainian, actually. So Chen is my last name. So yeah, you can call me Bainian, or you can also call me Brian if you cannot pronounce it. If you're not confident in pronouncing it. I'm a development engineer in Advanced Remanufacturing Technology Center under A-Star Singapore. A-Star is a research institute in Singapore. And we're also the ROS-Industrial Consortium Asia Pacific and the ROS-I Consortium in Asia Pacific region. And we're managed under the A-Star Singapore. So a bit about my experience. I actually, this is my first job, and I'm kind of like a newcomer here in the ROS community. And so throughout in my first job, I have worked with cobots, manipulations, as well as we also worked a bit on the RMF, which is one of our Singapore projects related to facilitating the interoperability between various robots from various vendors. And last but not least, I also work a little bit on the quality assurance side for the ROS-Industrial, as well as some of our projects that is funded by the Singapore government. So I'm honored to be invited here today as a guest speaker to share with you about quality assurance automation with industrial CI. So the talk will consist of three parts. First, I would like to give an overview on some of the goals for the quality assurance work ongoing here in ROS-Industrial Asia Pacific. Second, I will give a brief introduction on how to make use of industrial CI for your quality assurance pipeline, and also a preview of some of the new features that we're adding into industrial CI. Last but not least, I will discuss some of our future plans and development roadmap. Okay, so before we actually get started to the content, I actually created a quick short survey on what do you think on the software qualities and what you currently understand about it. So please just go to thementi.com and key in the code here, and yeah, and you can type in your answers here. Yeah, just describe in one sentence, why do you think software quality is important for ROS development? Okay, we have about 14 participants. We have 14 participants, so I'll wait for about like 10 answers and let's go ahead. So you mentioned that to improve the quality of open source projects, I guess that's software quality. Of course, where of course it can help in improving the quality of the open source project, so that more people will adopt in the industrial project. I think this is also valid. A lot of our members came to us, and the first problem that they have is with the open source project is this quality, is the software quality. And with certain measures that is implemented, we can show that for open source project, we're actually also adopting some of the processes commonly used in other big company, big corporation for software development. To catch bugs, especially in the edge cases, of course, with proper unit test and like system level testing, it can help with catching bugs. And however, whether you will catch bugs in the edge cases, it depends on what kind of test in the end we're running. Reliability. So of course, one of the key challenges in ROS and also a lot of open source project is that a lot of your dependencies are ever changing, and also when you're doing in your runtime with a lot of edge cases coming up, you need your program to be fully tested and continuously tested. Robot operates in safety critical environment where defects can cause material harm to people and property. I'm not sure how software quality can contribute to this. Maybe you can elaborate on this. So you can just unmute yourself and elaborate on why do you think software quality can help with this?
Latent defects often show up in unknown places. So having a very rigorous set of tests that you can prove that the software that you built is the software that you end up with is an incredibly important thing in environments where you rely on having things which are like that safe and operate in the way they should.
Yeah, yeah. So it's mainly on like the kind of the non-determinism that can cause kind of the like safety critical operation. Is that what?
Yeah, that's non-determinism, but defects can just basically be you believe that in the following case this is what should happen, and instead it doesn't.
Okay.
You can have other problems.
Yeah, so we should write. So there should be like test cases there for the program to go through before it goes into deployment, right?
Yeah, and then when you think about ROS core infrastructure, right? So deep problems in infrastructure, like things that are doing, kinematics and dynamics, can cause, very, very subtle, hard to find issues.
Yeah, that's true. That's true. Okay, thanks for your answers. And then robot interact with people and the physical environment, safety, functionality, and security are critical. Yeah, but I also like this is kind of loosely related. Not sure that software quality can directly contribute to this. Of course, the quality and security are hand in hand. They're not always the same, but parts of it, the software, the quality is not always addressing security alone. Then software quality is important for any software. That's true. I totally agree with this. Build trust in ROS, and software is meaningless without quality. It's like beer without water. Okay, that's an interesting take. Okay, let's move on to our to the next question. Let me see if I can. So yeah, just name one practice to maintain that you and your organization use to maintain software quality, or you think that you would like to see in ROS in the future that will incorporate in like the software quality management for ROS. Yeah, so one of the key practice for maintaining software quality is unit testing. With testing all of the function that you have written, as well as testing all of the edge cases that can cause your function to not behaving as predicted. It is very important to write unit tests, and with the help of code coverage, you can actually see whether all of your code has been tested, whether if all of the cases for your if statement is tested properly. With continuous integration, it can helps with continuously checking whether your software is working properly, whether all the dependencies are working properly, and whether your current APIs will affect your downstream repositories. And this is the main focus. This is also one of the main focus that I'll for today's talk. Simulation-driven testing, continuous simulation. I believe we have people from AWS here, and I think they're also investing a lot on looking at how to incorporate simulation in the quality aspect of the code testing site. Of course, documentation is very important. Okay, thanks for your answers, and I'll proceed to the presentation now. So, okay, so first, I'll give a quick introduction on some of the ongoing work for the regarding quality assurance here in ROS-Industiral Asia Pacific. So the aim of our quality assurance work package is to ensure the quality for the software packages that we, our partners, develop here in Asia Pacific. In this work package, we're collecting best practices and providing information about useful tools and their configurations. We also aim to improve automated testing framework to reduce effort needed for achieving and maintaining high levels of package quality. Lastly, through aligning within the ROS-Industiral community, we would like to provide a standard with acceptance criteria to evaluate whether packages are of high quality, well documented, and is actively maintained. So in the future, we'll also open source some of our findings and share it with the whole community after this work package is done. So here's a brief overview of the continuous integration workflow that we have drafted, and we also plan to create automated tools to judge on the result and tests that we gather and create a quality tier badge. I'll elaborate on that later. So through community alignment and improvement on continuous integration and automated testing and establishing standardized quality level acceptance criteria, we can achieve automated industrial grade quality for the ROS-based robotic software solution that we developed. Okay, so now let's hop in and discuss about why we chose Industrial CI for this work package. Because one of the reasons, because first of all, it was developed and maintained by ROS-Industiral, and that's us. And I think we have a relatively good track record of regarding software quality. So, okay, anyway, joking aside, however, it is also superior due to its ease of use, supporting both ROS1 and ROS2, and is easily configurable. It works with, it also works seamlessly on private and unreleased packages, unlike the ROS build farm, and is also widely used across the ROS-Industiral communities from Asia, Europe, and Americas. Also, some of the notable projects right now are using Industrial CI. For example, MoveIt now has adopted Industrial CI, and also various ROS controls libraries. Of course, for the release packages, ROS build farm is great. We also have identified some of the limitations. First, it lacks official support of code coverage, dynamic analysis, which is in our pipeline, and is currently still in the pull request stage, but those are currently available in ROS build form. Unlike ROS Build Farm, which is hosted by Open Robotics, Industrial CI primarily relies on shared runner resources provided by other cloud CI services like GitLab, GitHub Actions, and Travis CI, as well as Google Cloud Build. And for open source projects, so usually like GitHub Action, it is not a problem of running your CI. But for private and unreleased packages, sometimes there is going to be some runtime limit or runtime credit constraint for the hosted runner based on your building plan. However, nowadays with GitLab and GitHub Actions, they also provide options for you to use your own locally hosted runners. So these problems can be easily resolved compared to what is achievable from before. Lastly, due to the nature of shell scripting, Industrial CI currently doesn't really work well with macOS and Windows, unfortunately. So what is Industrial CI? We're following the tradition of ROS is technically not an OS. Industrial CI is actually not a hosted CI integration service by itself, but relies on various other CI platforms. Industrial CI is a collection of scripts that helps with deploying ROS-powered packages in CI. It supports Linux as the primary OS platform and various architecture, including ARM. It also supports all of the active ROS1 and ROS2 distribution, as well as some of the end-of-life ones. For ROS1, you can choose all of the available builder tools from the old Catkin Make to the Catkin build tools, and also CodeCon. For ROS2, it supports CodeCon. It also works well with a variety of CI services, including GitHub Action, Travis CI, GitLab CI, Bitbucket CI, and much more through your own customization. To find out more on what is currently available, you can also, you can also go into the official Industrial CI GitHub. And yeah, there is quick tutorials on how you can set up for various CI build services. Yeah, back to the presentation. So, here's an example in GitHub Action. You can type in the configuration files. We have examples on the Industrial CI GitHub repository. And after you commit and push your changes, multiple jobs will be run automatically to run source test, which I'll explain what will happen inside the source test. Then you will produce a comprehensive log with drop-down lists like this. You can also collapse the logs to see what is going wrong for your CI pipeline. And last but not least, it will generate a build pass batch for you to put on your README or on your repository to show that it is continuously passing. Next, for GitLab CI, similar things can be done, and it can also work with various private repository as well. And similarly for Travis. Okay, let's go into details on what happened during a source test defined by Industrial CI. Recently, Industrial CI allows you to specify the layer of isolation for your source test process. So let's first look at the Docker isolation scheme, which is the default scheme for before. First, your repository source code will be cloned inside the Docker or the VM that is run by your CI services. Then the scripts, the before scripts that's specified by the CI will be run next. And then based on what you specify, what your upstream dependencies are, for example, you have, it depends on MoveIt2. MoveIt2 is not released at this moment as binary. You can actually specify what is the repos that you want to clone, and you will clone inside your repository. You will automatically install the upstream dependencies through ROS-Deb and build the upstream dependencies that you want to use. Next, the target workspace here will be the code that you clone from here. So you will install your target dependencies through ROS-Deb, build your target dependencies, and run all the tests that you have specified, whether it's your unit test, whether it's your static analysis, it will all be run here. Then you will go to the you can also specify various downstream dependencies, and this is actually extensively used by the TestDirect project to test the downstream dependency that depends on their project. For example, your ROS wrapper, your ROS2 wrappers, that is mainly based on the mostly C++ kind of repository. Yeah. So then you will run the after script after exiting the Docker, ROS Docker, and you can generate the build badges here. And a good thing about this is that you can also reuse the ROS Docker after this. Okay. So now we also have source, the shell isolation. For shell isolation, you don't really need to have a Docker architecture. Instead, you can directly use the ROS Docker as kind of the Docker that the CI service runs. However, this is, I don't think this is available right now in Travis, but it's available in GitHub Action, GitLab CI, and Bitbucket CI. So this is one of the example that industrial CI does, is that based on the kind of functionality that provides by various CI services, we're also constantly improving and to leverage more advanced kind of functionality provided by the CI service itself. So there are also other notable features inside industrial CI that I think is very useful. You can run the pipeline locally, which you don't have to push it every time to test the pipeline. It works in private repositories, and you can run customized ROS Docker to shorten the build time. It also provides build with Ccache to improve your building speed, particularly for large C++ project. After your first build, your subsequent build with no major changes will actually build much faster than before. You can also check if there's any ABI breaks compared to the previous branch, commit, or tag, and that is very important if you are committed to a versioning scheme such as the semantic versioning, where you have to guarantee that there's no breaks between minor release. It also you can run customized pre and post process command within each action represented in the previous diagram. You can run a kind of action right after installing the upstream dependencies or after you build the upstream kind of workspace. Next, you can also reuse the Docker image to speed up the next build. And this feature is actually utilized in MoveIt nowadays. In light of some shortcomings, we're also in the process of fixing them. So some of the changes will be merged in very soon. We're still in the process of getting most of it done. So one of it is generating code coverages, and you can specify which kind of code coverage reporting service that you want to use and what kind of path, whether it's relative path or the absolute path you want to exclude it from your code coverage report. And yeah, so in the build log, it will generate your code coverage report, and you will upload to remote to generate the web report. This one is actually in codecov.io, and this is in coveros.io. You can see which lines of your code is covered. However, it doesn't, right now, some of the code coverage services doesn't really tells you what branch, which is how much of your each statement, whether it's true or false, is actually covered. So yeah, this is one of the limitations there. For some of the code coverage reporting services, you will also automatically comment on your pull request, which is also very good. Here are currently some of the code coverage services that we're supporting, and some of the other things that we're looking at. And we're also able to combine Python and C++ report for both ROS1 and ROS2, which I think is also one of the limitations right now, because for a lot of the projects, especially written by developers, there are both Python and C++ code involved, and most of the time we only cover the C++ part. So also one of the key elements in ROS2 development is that they have run dynamic analysis. For example, address sanitizers and thread sanitizers for a lot of the core components, and that is also one of the things that we would like to add in for industrial CI. Address sanitizers can check for memory leaks on your unit test as well as your system level testing, while a thread sanitizer can check for data erasing. And these are the logs that it can generate while you're running the test. So here are also some useful tools for CI pipeline, mainly on the static analysis side. So for static analysis, you can check whether your code is formatted properly, whether there is any glaring mistakes, even without actually running the code. You can also check for whether you have copyright statements before your code or inside your packages. So of course, amount-link is one of the ROS2 command line like the ROS2 go-to tools if you want to run static analysis. It has ROS2 command line commands, and it also provides CMake macros for static analysis. Another one that you can also look at is compiled by Swery. It involves a lot of the CMake macros for running common tests. Okay, so there are still limitations on the documentation and specification side, especially on the industrial CI. So we are still working in progress on the specification document to summarize commonly used tests and test configurations. And we're also updating the industrial CI documentations to provide step-by-step examples on how to setting up tests and fix the test problems encountered by the users of industrial CI. Right now, there are a lot of FAQs inside industrial CI. So if you have any problems using it, you can first look at the FAQs, you can also submit an issue, and the maintainers will be very happy to answer any of your questions. So yeah, and another thing is that with the REP 2004 community guidelines for software quality assurance have come out, we are also looking at tutorial-oriented documentation on step-by-step how to reach a level 1 quality. Yeah. Another big plan that we have is to provide these Qt quality badges. I think right now this is not the priorities for our previous packages, because we also have limited resources, but we also plan to do this in the future. We intend to use REP 2004 as a criteria for providing these quality badges. However, we also understand that REP 2004 is intentionally generic so that maintainers and developers are not tied down into using only a specific tool for meeting certain criteria. We currently envision it to be a hosted service that is easily deployable and highly customizable. I've also listed down some of the examples here, like Codacy, CodeClimate, SonarQube, and GitLab, and also GitLab. Jenkins also have its own. However, these services doesn't meet all of the criteria, and sometimes it's tied down to one specific, like code formatting tools or a testing tool. So here is the proposed architecture that we have. So first of all, based on your quality declaration, the hosted service will either test your criteria automatically or require reviews from the maintainers. For the ones that can be checked by continuous integration, like test and coverage results will be uploaded as artifacts and for further quality determination. And this part we have already, in industrial CI nowadays, you can already expose those test files as artifacts. Since some of the requirements are also organizational, we propose that a certain GitHub application needs to be created to gather some of these information of the repository in order to test automatically. After the criteria are met and the ones needed for reviews are done, the quality level will be updated and we can provide a quality badge. We can also in the future have bots to comment on PR or elsewhere as well. In the later part, I have listed down what are some of the parts that we can test it based on the REP 2004 metrics. So this is combined by my, compiled by my colleagues, Beihao Yun, or you can call him Gary. So we have divided all the requirements into the 7 metrics to specify, and we have think deeply on what can be done automatically and what can be done through review. Yeah. So for the versioning policy, as I mentioned before, the semantic versioning policy can be tested through some of the functions that is provided by industrial CI, like API breaks and API breaks. But of course, this needs review. And for change control process, some of the existing tools are actually tracking how long it takes to address some of the issues that is proposed. And yeah, so probably we need some kind of GitHub integrations in there. So for documentation, we can check whether there is a declared license or whether there is like copyright statements and whether there is a quality declaration there and what is the current quality, your quality level for your repository. But for some of the other things that there is requirements for review there. For automated testing and nearly all of the things can be tested automatically, and that is why industrial CI is recommended to do all of these tests. Next, for dependencies, reviews are required for non-ROS dependencies because, as is stated here, that for non-ROS dependencies, you also need to apply all of the criteria that is defined in REP 2004 and evaluate the quality level separately. For the ROS packages that already has a quality badge, we can just make use of that quality badge to determine whether your dependencies whether your dependency has a lower quality level compared to yours. For platform support, we have to leverage ROS build farm, or in the future we'll also be looking at supporting Mac OS and Windows maybe in the future. Yeah, for security, it's relatively brief here. Yeah, and here is our development roadmap. As I mentioned before, the quality criteria implementation, we're currently having a bit of delay. However, we have come up with a draft for specification for the quality criteria, and we're on track to releasing them. Yeah, here is some of the acknowledgement and contribution from other people. So first, Matthias is the industrial CI maintainers, and I have worked closely with him on this presentation. Next, we have Daryl and Eric, who is my manager. And we have various other members who have contributed to the testing of the code coverage capability. And we have some of my other colleagues who have worked on this part. Yeah, so that's all for my presentation. I'm welcome to for any questions that you have. Yeah.
Thank you. So, questions?
I have a quick question for you. So the ROS tooling working group through the ROS Technical Steering Committee maintains a GitHub Actions as well. I was wondering if you see any convergence between those, the ROS and the industrial CI and the ROS tooling CI.
You're muted.
Sorry. Yeah, thanks, Lou, for your questions. And are you referring to the ROS CI tool from that is used for ROS build form?
No. So if you go to the GitHub ROS-tooling, there's a CI for ROS2, ROS1. That's a GitHub Action. Supports Linux and Windows. I was just wondering if there was a convergence plan.
Sorry. Maybe you can drop a link there.
Sure, I'll drop a link in the chat.
Yeah, so I think if we're just looking for like implementing in GitHub Action, okay, thank you. Yeah, I'm not really aware of it, but I think I can also link up with the industrial CI developers to see whether there is any synergy. There is synergies with them, and we'll also looking at possible convergence of the two. But for the general look of it right now, this only applies to the GitHub Action. So if you're having your code in GitLab or somewhere else, probably industrial CI is the tools that you can look for. But for GitHub Action, you can also look for this. Yeah.
All right. Anyone else has questions? I have one, Bainian. So have you tested the system, or what's the experience been in terms of scaling? How many tests have you seen people run with the industrial CI tooling in parallel?
Okay, so we have actually collected some statistics regarding the Git clone of how many times the industrial CI actually clone, because actually to run a test on industrial CI, first of all, you have to clone the industrial CI into your CI pipeline. And I think in the industrial CI packages, there are actually statistics posting out on how many times it is cloned. I think
my question is really as people start to use the industrial CI tooling to test, let's say for regression testing, and you're building your pipeline where each time you check in code, you have multiple variations of the code. Let's say you're doing parameter testing or something of that nature, and you just have, like, you bring in variables, you want to test 500 different parameters as a batch process. Have there been any limitations to the scaling of the testing in parallel using industrial CI? That's really where I was coming from.
Okay, so actually for industrial CI, we don't usually handle the batching process. In industrial CI, you can actually specify using things like matrices, and you can actually specify the different parameters for your different jobs. But the actual job is not run by industrial CI itself. It's run by the CI services that is provided. For example, if you have GitHub Action, how many batch of jobs you can run simultaneously depends on how many batch of jobs that your GitHub Actions can run, which depends on your billing plan.
I see.
Yeah, and yeah, similarly for GitLab and other CI service that you want to implement, like Jenkins or so on and so forth.
I see. Okay, so in terms of the tooling itself, there's no constraints, or it's really independent of the tooling. It depends on how your setup is. Got it.
Yes, correct.
Thank you. All right, other questions? Have folks on this call, have you all been using CI integration as you test your applications?
I think like especially when you're in the early stage of your program development, it's not really like sometimes it's probably not necessary to go with the CI kind of deployment, but especially when your teams becomes larger, or when like stability, as well as you would like to release them in cycles, continuous integration is definitely crucial there, because you don't want like, of course, code reviews is also important, but it's also necessary, but you don't want the reviewer to run your code all the time, setting up a new PC to do it. So I believe continuous integration can help a lot on that.
Yeah. Definitely. I will say that, you know, in my having spoken with several robotic developers, that's definitely been a pretty high demand use case, especially as use of simulations, that usage matures. That is one of the first stops. Like, how can they do this in an automated manner? Yeah. All right. If no other questions, Mike, we have the Gather link. There it is. Okay, so if you're new to this meetup, we usually break away from the Zoom call around this time, and then hang out on the Gather platform. So if you're new to the platform, it allows you to just like gather in as small groups. It's a cool platform. So click on that link. I will keep this bridge open for anyone who's still testing it and not able to get in. But if you click on that link, it'll open up a different window for joining on Gather, and I'll hope to chat with you there as small teams and informally. So see you all there. Okay.
Yeah, thanks everyone. Okay. Yeah.
Thanks, Bainian. Hopefully you're joining there, so we can chat with you there.
Yeah, sure. I'll be there for
Perfect.
a while.
Yep.
Thanks for the talk.
Thank you for the talk. Yep.